Why I never use non-parametric tests like Mann-Whitney or Wilcoxon tests. The reason is quite simple. It changes the null hypothesis that we're testing for something that we're usually not interested in. So the story usually goes like this. We have a control and a treatment group. We're planning to use a t-test to compare the means. But for some reason, we decide to move on to a Mann-Whitney-Wilcoxon tests because we think that the data is not normally distributed. The problem is that we often see in books or on blogs or stuff like that, that this is a valid procedure because the Mann-Whitney test is testing for a difference in medians. So we're just switching means to medians, which seems sensible. But that's not true. The Mann-Whitney test is testing for stochastic superiority. What is that? Exactly. It's like an abstract mathematical idea that most people don't understand and is not relevant to most questions. The misconception comes from the fact that when the data is unimodal, right, and symmetrical, the Mann-Whitney-Wilcoxon test will reduce to a test of medians. But if the data is unimodal and symmetrical, the t-test will work fine, even if it's not perfectly normal. And we can see this in a bunch of simulation data that was done over the decades by statisticians. You can see in simulations that the Mann-Whitney test will sometimes reject two samples with exactly the same median because it's sensitive to a bunch of other features in the data, like skewness, variance, modes. So it might reject the test for reasons we don't care about. Let's say one sample has more variance than the other, and that's not what we want. So what I do 99% of the time is I use some form of robust t-test. For example, the Welch t-test, which is the default in R, and it's implemented in a bunch of other software.